Okay, now let's finish example 9. My battery was running low. So here we go. You let 5, you bring 5 as a constant out here, and then you have e to the u. Now look, x dx now, what would you substitute x dx? Because right now, remember, we convert everything into u variable. So look, x dx right now is that guy right there, which is what? That's right, 1/2 of du. Here we go, 1/2 of du. There we go. Okay, so now everything is in u variable. Can I bring 1/2 out? Correct. 1/2 out. That's not 1/5, Mr. Dan. That's 1/2 right there. Okay, 1/2 time with 5, and now this guy is e to the u du. Ta-da! Okay, man, look right here. 5 over 2, sorry, 5 over 2, e to the u, integration of e to the u du, what you get? Yep, e to the u plus c. There we go. Simply, right now, just plug the value back in, which is 5 over 2, okay, distributive, you get e to the u, but u is what? U is right here. U is negative x squared, and then distribute this time, that would give you another value for c. I'm going to put red ink for you right there. Okay, with that, we conclude example 8, and you have similar homework problems just like that. Okay, stay calm, review the videos, and you will get this. Okay, let's tackle example 9, shall we? Okay, I'm gonna erase example 8 and let's move into example 9. Okay, here we go. All right. Okay, here we go. Example 9, integrating exponential function. You have right here, I think I will just do b for you, okay? Because b looks attractive. We have right here sine x time, okay, that's time, e to the cosine x dx. Okay, it looks a little bit, intimidating, but don't let that bother you. Again, something looks strange doesn't mean it's hard. Again, look at this problem with me. Tell me, what bothers you right here? I don't like that guy, sine and cosine, you love math like sine loves cosine. So you see right here, you wish to turn e to the u exponent. And if you let this cosine x, let u equals cosine x. And when you take derivative of cosine x, what you get? That's right. That is right. Sine x. So you see it is set up for you right away. So to apply the formula so that you can integrate this problem, then you let u equals what? Cosine x. There we go. Now you ask, why do I let u equals cosine x? Because only when I have the form e to the u du, then I can integrate that. And that's why I let whatever exponent of e equals u. Okay, here we go. Take du over dx, okay, which is, there we go. And that's right here. Look at this, look at this. Make it, take d over dx of u. The derivative of cosine is what? That's right, negative sine. Okay, so there we go. Negative sine, and now you what? Du equals what? Negative sine x dx. You bring the x up there. Everything is set up for you right here. Almost everything. What you don't need is this negative. See it? You now have sine x dx. You have sine x dx. I don't need negative. So what do? Yep, that's right. Time with negative. I don't have space, so I just do that for you. So that now turned into positive. And now you have sine dx equals negative du. All you do right now is, plug it in. So now this turned into what? This now turned into, okay, sine, there we go, look, e to the cosine e to the cosine, which is e to the u. There we go. Got it? Convert everything from x to u. And then your sine x dx. Sine x dx is what? Sine x dx is your negative du. There we go. It's not that bad, right? Now all you do is just finish this formula right here. Negative e to the u plus c. It doesn't matter if negative c or positive c, okay? So now, because we don't know what c is, so now all you do is just convert, just put back in the x variable, which is negative e to the cosine x plus c. And the task is done. All right, just simple as that, right? All right, I think I will pick another or two examples from example 10. Okay. Would you take a look at example 10 for me, please? And I think you know what to do. The one problem that looks easy but doesn't mean, it looks familiar but doesn't mean it's easy. Okay, would you look at example 10 for me, please? Example 10 coming. All right, go. Example 10. All right, this is a pretty common mistake if you are not careful. Let me write another one more time for you. Ex plus c. There we go. These two formula right here. Okay. All right. This one is in a variable of a function of x. So look at this right here. Example 10. Example 10. You have now we have a definite integral, which means you are now, the answer right now is a constant, a real value. It's not in a form of a function anymore. So e to the negative x dx. Look at this. You have from 0 to 1. Okay. This could be a problem that you can interpret. Okay. You can interpret which is the finding the areas of the curve e to the negative x with the two upper bound and lower bound from 0 to 1. That's the two vertical lines. Okay, here we go. Look, from this right here, and you wonder, Mr. Deng, do I use this formula or do I use this formula right here? Notice, this one you can execute right away if this is just exactly as it is. E to the x. Got it? There is no exponent, which is like there is no x squared, there is no 1 over x, there is no negative x either, because if there is something other than x itself, even the sign has to be exact so that you can get the direct answer. This guy is not that guy. What's the difference between this and this? Correct. The negative x. That's a tricky part. Be careful. Therefore, which formula are you going to use? That is right. That is right. You got to use this guy because this is not exactly as that guy. Therefore, your job right now is to let u equals what? Exactly whatever that is right here. Negative x. Now, du, I'm going to do a quick evaluation for you right here. Du equals right now negative what? Dx. There we go. You know, I do d over dx of u, and that's right there. Just, okay, negative 1 times dx from up here. So there we go. You got everything right here for you. Got it? Now, plug this in. Plug this in. Before I do that, I need to do one more thing. Now, look, watch out for the changing of variable. If I let u equals negative x, I need to also turn the variable of x values into u value. Look at this. Okay, here we go. I let u equals negative x. So the first point, when x is 0, here you go. When x is 0, what is y? What is u? Okay, if x is 0, then, oh, good. You have negative 0, which is also 0. Yep, when x is 0, u is also 0. There we go. X 0, u is also 0. There we go. You see it? Make sure it's there. Good. Now, what if x is now 1? There we go. If x is 1, what is u? u equals -1. There we go, -1. All right, there we go. You see it? I can clear it for you. We're almost done, y'all. Okay, so e to the -x. What is your -x? That is u. And then your dx right now is what? I know, I owe you one more step, right? You bring negative over here, which is negative du equals dx. There we go. Now everybody is in place for you to execute that. Okay. E to the u and the, now let's evaluate the area under the curve of that. Okay. Are you ready? What do I put negative here, guys? What I put? Oh yeah, that's negative right there. That's right. Okay, there we go. Negative. All right, are you ready? Here we go. Here we go. All right. Plug this in. Plug this in. Okay. You can put the negative out. Okay. Keep the negative out right here for me. Okay. E to the -1. Got it? E u -1 minus e to the what? 0. There we go. Got it? Okay. I just remember, guys. Hope you remember. A, B, a definite integral f of x dx. That is what? The antiderivative of b minus antiderivative of a. There we go. Just so you know. So now what do we have here? A negative right there. E to the -1, which is what? 1 over e. Okay, what is this guy? That is 1 right there. Okay, -1. Okay, because, I mean, I can use parentheses, but Mr. Dang, get your notation correct. All right, here you go. Okay, all right. I don't like this negative out here. Distributive in, what you get? 1 plus, okay? Ooh, 1 minus, sorry. Look, distributive in, you got 1 minus 1 over e. Bingo. That's your work. You plug in e, which is 2.71 and so on. You will get 0.632. The task is done with part A. Just be careful with the tricky part right there. You have to let that equals u. Okay, guys? I'm gonna pick C because C looks pretty cool. And you like trigonometry. Yes, you do. Okay, all right, here we go. Let's do C and I'll leave B for you, okay? We do C and then we conclude the lesson today, which is enough for the whole week for you to watch and review. And then I will post your homework on RenWeb for you. C, it is C, -1 from 0, and you have e to the x, and cosine, the angle here is e to the x, dx. There we go. Okay. All right. We good? Okay. Talk to me. Talk to me. What bothers you right here? You say, Mr. Dang, I know how to do what? I know how to do integration of sine u du. I know how to do, integration of cosine u du. But the ex, I don't know. Of course, if you don't know, sorry, I just kicked my video. It's still good. I just need to be careful. Okay, here we go. Then if you want to make this u, what do? We are math people. Come on. Make your call. You are given the power of math principles and do it. Yep, that's right. Let u equals what? There we go. E to the x. Come on, guys. Rule your math right here. Subdue your math right here. Okay, you got that power from math principles right here. Let u equals e to the x. All right, what did you do? dx of u. There we go. Equals what? What is derivative of e to the x? You take derivative both sides. That's what I'm doing. Take derivative both sides. D over dx, which is u prime over, itself right there. Derivative of e to the x is itself. Okay, now can I bring the x over? Okay, bring the x over. Which you get? Du equals right now what? Ex. x. That is it right there, guys. Now you can convert the variable x into u for me. Okay, all right, there we go. Look at this. You now have cosine. Look at I know we're gonna in a moment we will do this. Okay, do the upper bound and the lower bound in a second, but look at this right here. Cosine e to the x. Cosine e to the x. What is it? Yep, that's what we want to do intentionally. Cosine of u. Your dx right now is what? Your dx right now. Look. See this right here? And that right there. Perfect. That's, the problem is set for you just like that. Yummy problem. E to the x dx right there. Now the whole thing turned into what? Just du. It's a clean shot for you. So that's du for you right there. Okay, am I missing anything right here? I don't think so, right? Okay, so there we go, guys. There we go. So I have successfully convert all x variable into u variable. The only thing right now is, Mr. Dan, if you want to do it in terms of u, you gotta, convert this guy as well. No worry. Let's go. U equals e to the x. What if x is, let's say, -1? Yep, if x is -1, what is the value for u? Well, that would be, if x is 1, then e to the -1. There we go. If x is -1, so the u equals what? E to the -1. Yep, don't let that bother you right there. Cool? Okay. What about when x equals what? 0. Okay, when x equals 0, plug it in. E to the 0, which is 1. So when x is 0, u equals 1. Correct. Ta-da! The task is almost done. Your job right now is just integrate this for me. What is the integration of cosine u? Correct. Sine u. And then upper bound and lower bound right here and 1 right there. So finish your job, please. And that is sine of, look, b minus a, which is 1 minus sine of, okay, what is it? E to the -1. There we go. And your job is done, guys. Just plug it in your calculator. You shall get 0.482. Perfect. Okay, everything is set for you, and you can review the videos, and I will post homework for you on RanWeb. I miss you guys. See you then. Have a wonderful day. Bye-bye.